40 minutes are completed. Again, the new session is already started. I request all the students, please join on time. If you didn't join at time, so this will happen because already 40 minutes are completed. Again, I'm going to start the second lecture. Some students are in waiting room. I will admit and I will start again. So 39 participants are there. Forty. $41. Yes, we will start again. Yes, again we'll start. Yes, these are the names given, common names and IUPAC names. How to write the IUPAC names in 11th standard, I already explained. How to give the IUPAC names. Yes. See, in this is a dihalogen derivatives in which two hydrogen atoms are replaced with two halogens. The name is methylene chloride. IUPAC name is a dichloromethane. This is ethyl bromide, in which one hydrogen is replaced with bromine. It is also called as bromoethene. All this is explained in last year also in the chapter hydrocarbon. So I'm not going to take in detail. This is the homework given for you. We have to write the structures of the 2-iodo-3-methyl pentane, 1-chloro 2,2-dimethyl propane. This is a homework, today's homework. This is a solved example I have given here. Draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. name each of the isomer according to the IUPAC system and classify them as primary, secondary, or tertiary bromide. This example is already solved here. Just go through it. Another question is given here. Write the IUPAC names of the following. Some students are still in waiting room. I'm going to admit and again we will resume. Okay. So write the IUPAC names of the following. This is also given for your homework. The answers are also given. If you have any doubt, you can call me after the lecture is completed during the when we are going to complete this homework. If you have any doubt, call me. I will solve your doubts. Also, one question is given here. Write the structures of the following compounds: 2-chloro-3-methyl-pentane. This is based on the IUPAC nomenclature system. Now, the most important part, which is important for exam, methods of preparation of alkyl halides. We are going to start. First one is by using alcohols. Alcohols, you know, in 11th standard already we studied. What is meant by alcohols? These are the organic compounds which contains hydroxyl group, which is bonded to the aliphatic hydrocarbons. These are called as alcohols. Many types of alcohols are prepared by using, many types of alkyl halides are prepared by using alcohols. In this OH group is replaced. Remember, this OH group is replaced with X. Means ROH is converted into RX. Such type of reaction is occurred by using alcohols. Means OH group of alcohol is replaced with X. See here in detail it is given. The OH group is replaced with halogen atom. There are 3 reactions by using halogen acids, HX by using phosphorusalites, and by using sulfonyl or thionyl chloride SOCl2. First one we will discuss by using hydrogen halide or halogen acid HX. So in this reaction, hydrogen halides reacts with alcohols to give different alkyl halides and water. Order of reactivity of alcohols is tertiary react first, then secondary, and last is primary alcohol. One example is given here. ROH plus HX with the suitable conditions. It gives OH is replaced with X, and this H combines with OH and gives the water molecule. Then alkyl chlorides. See, alkyl chlorides, this ROH is converted into RCl by using the reagent anhydrous ZnCl2. This is a special type of reagent. The combination of HCl, concentrated HCl and anhydrous ZnCl2, this specific combination is called as Lucas reagent. Remember the name. This may be asked for your exam. What is meant by Lucas reagent for 1 mark or MCQ? Alkyl chlorides are prepared by using alcohols with a Lucas reagent. Lucas reagent is the combination of, in bracket it is given, mixture of concentrated HCl and anhydrous ZnCl2. And the process is called as Gru's process. The reagent is Lucas reagent and the process is called as Gru's process. Remember the name. In this, primary, secondary, and tertiary alkyl halides can be prepared. Chlorides can be prepared by using alcohols. Some examples are given here. See, ethyl alcohol on reaction with HCl In presence of ZnCl2, it gives ethyl chloride. See, this is ethyl alcohol plus HCl concentrated, ZnCl2. It gives C2H5Cl. This OH is replaced with Cl, and this hydrogen is combined with OH and gives the water molecule. So if you understand the one reaction, you can convert. Some students having the doubts. Just a minute. Yes, after the lecture, you can call me. I will solve the doubts. Isopropyl alcohol on reaction with hydrogen chloride in presence of ZnCl2, that is a Lucas reagent, it gives isopropyl chloride. Say this is isopropyl alcohol, this is the secondary alcohol. In this OH is attached to the, this OH is attached to the carbon atom, which is secondary. HCl, ZnCl2, this OH is replaced with this Cl, we get isopropyl chloride. This is isopropyl alcohol, this is isopropyl chloride, only the OH group is replaced and water molecule is formed. In case of tertiary butyl alcohol, the reaction is carried out only the concentrated HCl. In this, ZnCl2 is not required. So remember, this is an exception. Only for tertiary alcohols, the reaction can be occurred with concentrated HCl at room temperature, and the forms also propyl chloride. Sorry, the tertiary butyl chloride. This is a printing mistake. Tertiary butyl chloride gives tertiary butyl. Sorry, tertiary butyl alcohol gives tertiary butyl chloride. This OH is replaced with this Cl in presence of concentrated HCl only in absence of ZnCl2. Then alkyl bromides. In the previous reactions, we already prepared alkyl chlorides by using alcohols. In this reaction, we are going to prepare bromides. Alkyl bromides are prepared in presence of NaBr and H2SO4. I will explain what is this NaBr and H2SO4 and why this is required. Like HCl, we can't prepare HBr because this is unstable. It is prepared in situ. In situ means at the time of reaction mixture, and then it reacts. So alkyl bromides are prepared by heating alcohols with concentrated hydrobromic acid. Hydrobromic acid, this is HBr. This is being unstable. It is prepared by treating sodium bromide. Now this is NaBr plus concentrated H2SO4 in situ. In situ means this is HBr is produced at the time of reaction mixture. At the time of reaction, it is prepared and then it reacts with OH, and we get the alkyl bromide. See, so one example is given here. Ethyl alcohol on reaction with hydrogen bromide. Remember, always remember this HBr is prepared by using NaBr and H2SO4 in situ at the time of reaction mixture. So HBr being unstable, it is prepared in the reaction mixture. In the last example, we already seen this HCl is stable. So this is not prepared in situ, but HBr is prepared in situ, and we get the C2H5Br. This OH is replaced with Br. Ethyl bromide, ethyl alcohol to ethyl bromide. For the secondary and tertiary alcohols, remember this note is very important. For secondary and tertiary alcohols, dilute H2SO4 is used instead of concentrated H2SO4. If the concentrated H2SO4 will be used, it will dehydrate these alcohols into alkenes. Dehydration reaction will take place. So remember the notes. So this is the secondary. This is the secondary. Some students are there, I will admit. Okay. So see this isopropyl alcohol on reaction with HBr. This HBr is prepared in situ by using this NaBr and H2SO4. This OH is replaced with Br and we get the isopropyl bromide. So this is an example of tertiary alcohols. This is tertiary alcohol plus HBr, same reaction, OH is replaced with bromine, no any change in the reaction. Now the alkyl iodides. In the previous examples, we already see how the bromides are prepared, how the chlorides are prepared. Chlorides are prepared by using Lupas reagent and Gru's process. Then bromides are prepared by using NaBr and H2SO4, and the alkyl iodides are now prepared by using heating alcohols with sodium or potassium iodide, NaI, this is sodium iodide, plus H3PO4, this is phosphoric acid. In this, again, HI is generated in situ. This HI being unstable, it is prepared at the time of reaction mixture by using sodium iodide and H3PO4. This is a phosphoric acid. HI is prepared and then it reacts with alcohol. OH again replaced with iodine and H2 molecule is removed. One question is very important in this. I have given the note here again. In this reaction, phosphoric acid is used. This H3PO4 it is used instead of concentrated H2SO4 because see here carefully, H2SO4 is an oxidizing agent and HI is a strong reducing agent. So if the H2SO4 is used, what will happen? The HI will reduce the sulfuric acid. What will happen? HI will reduce the sulfuric acid to the sulfur dioxide and itself get oxidized to iodine. So due to this reason, H2SO4 is not used, H3PO4 is used. Remember this. Now the next reaction is by using phosphorusalites. There are two phosphorusalites, trihalides and pentahalides. These are the stable. First one is reaction with phosphorus trihalide. Trihalides, this may be PCl3, PBr3, PI3. Trihalides, alkyl chlorides are prepared by using the alcohols with PCl3. 3 molecules we have to use here. 3 molecules of ethyl alcohol plus PCl3. It gives ethyl chloride plus phosphorus acid. Alkyl bromides and iodide same because this is unstable. We have to prepare in situ by the reaction of PBr3 and PI3. See, these examples are given here. 3 molecules of ethyl alcohol plus PBr3. This PBr3 is prepared in situ by the reaction of phosphorus plus Br2, and the reaction is same as ethyl chloride. Ethyl bromide, same, this OH is replaced with Br, this OH is replaced with iodine. For primary, secondary, tertiary alcohols, the reaction is same. Now the reaction with phosphorus pentachlorides, PCl3. Ethyl alcohol when replaced with PCl3 forms the ethyl chloride. See, in the last example, for PCl3, we are using 3 molecules of ethyl alcohol. In this, we are using only 1 molecule of ethyl alcohol, and see the byproducts here. If this OH is replaced with 1 Cl will replace here. Then 4 Cls will be remaining. 1 will be combined with HCl, and the 3 Cls will be combined with this PO, which gives phosphorus oxychloride. When we are going to write the reaction, we will understand. Then this is example of isopropyl alcohol. This is isopropyl alcohol. C, this is secondary alcohol. PCl3, OH is replaced with Cl, and the remaining byproducts are same. Yes, Pandey. Pandey having the problem? Yes, Pandey, you can ask me after the lecture. Now the next one is by using sulfonyl chloride, or it is also called as thionyl chloride, and the process is called as Darjan's process, remember. Alcohols when react with SOCl2, SOCl2 is also called as sulfonyl chloride or thionyl chloride. Sulfonyl chloride or thionyl chloride. We get the mixture of two gases here, SO2 and HCl. Directly we will see the example, then we will understand. See here, ethyl alcohol plus SOCl2. Alkyl chlorides are prepared by using this SOCl2, thionyl chloride. We will get the ethyl chloride, and these are the gases HCl plus SO2. Two gases are removed. This is the best method of preparation of alkyl chlorides. See, in this slide, I have shown all these previous reactions at a glance. First reaction is, this is with Lucas reagent, HCl ZnCl2. This is second one is the preparation of bromides. Preparation of bromides, NaBr plus H2SO4, this HBr is prepared in C2. Then the third example is PX3, phosphorus trihalides. This is a pentahalides. This is PCl3, this is phosphorus plus Br2, phosphorus plus I2. This is for PBr3 and PI3. And last one is Darjan's process. This is thionyl chloride. So all these reactions we can remember at a glance. Next. Yes, we will continue the lecture. 9:30 to 10:15 lecture we can conduct here. So the second lecture will not be conducted. Continuously 2 lectures we will take. If you are agree, we will continue. Otherwise, we will take a break. Wait, I will unmute you all. Yes, we will continue, or we will take a break here. Wait.
Sir, I think we should. I think we should continue.
Okay. Okay, we will continue. You are understanding these reactions or not?
Yes, sir.
Okay,
if I will in doubt, I will call you.
Okay, we will continue. The next part is from hydrocarbons. Hydrocarbons, these are the compounds of hydrogen and carbons. In 11th standard, we already studied the hydrocarbons. Remember, alkanes, alkenes, alkynes, aromatic compounds, these are the hydrocarbons. By using these hydrocarbons, also we can prepare the alkyl halides. See, first one is by using alkanes. By using alkanes, we can prepare alkyl halides, but many mono, di, polyhalogen compounds are formed. So this method is not used actually for the preparation of alkyl halides due to its limitation. Its limitation is we get the mixture of compounds, mono, di, tri, more than, if the more than one hydrogen is replaced, it is called as polyhalogen derivatives. In this, someone unmute. Mute your mic yourself. Yes, I have unmuted now. Yes, what is the drawback of this reaction? Remember, We can prepare the alkyl halides by using alkanes, but the drawback is we can get the mixture of many alkyl halides. So this method is not used for the preparation of alkyl halides. This is a very good method. Second one is by addition of hydrogen halide to alkene. See, this reaction is also completed in 11th standard. You know, in addition reactions in the chapter hydrocarbon, the alkene part was there. See, this alkene means the compounds which contains carbon-carbon double bond here. There are two types of alkene. Symmetrical alkene means the groups across the double bonds are same here, CH2, CH2. This is symmetrical alkene. And unsymmetrical alkene means the groups are different. So by simple, one example is given here. Ethene react with hydrogen chloride to form ethyl chloride. This is a simple addition. One hydrogen is added to this carbon and the chlorine is added to the another carbon across this carbon-carbon double bond, and we get here ethyl chloride. See here, this is a simple addition reaction. Also one example is given below. Ethene plus HBr, it gives ethyl bromide. See, this is again simple addition. Hydrogen can be added to this carbon or this carbon across the carbon-carbon double bond, and we get the product ethyl bromide. This is an example of symmetrical alkenes. In case of unsymmetrical alkenes, see, I will give the example of unsymmetrical alkenes here. See, unsymmetrical alkenes here, see the double bond here, this group and this group is different. This is CH2 and this is CH3CH. That's why this is unsymmetrical alkene. The name is propene. If the HBr is added to the propene, we get the two products here. Why the two products? Because this is unsymmetrical alkene. The first possibility is if, see the first possibility, if this hydrogen, sorry, see what is the first possibility? This hydrogen can be added to this carbon or hydrogen can be added to this carbon. If this hydrogen is added to this carbon, this is already explained in chapter number hydrocarbon in 11th standard, but again I am going to explain because this is very important part. Markovnikov's rule we have to apply here. What is the Markovnikov's rule? I will explain. In case of unsymmetrical alkene and addition reaction, the negative part of the reagent, it gets added to the carbon atom which contain less number of hydrogens here. See this carbon carefully, only one hydrogen is there. So this bromine is added to here. Bromine is added to carbon number, this carbon number 1 and carbon number 2. So the major product will be this isopropyl bromide, or IUPAC name is 2-bromopropane. 2-bromopropane. See, this is a major product because according to the Markovnikov's rule, what is the Markovnikov's rule? Markovnikov's suggested one rule to identify which product is major. So what is the rule? I will explain the rule here. See, this rule is given here. When an unsymmetrical reagent adds to the unsymmetrical alkene, this is unsymmetrical alkene and this is unsymmetrical reagent, then what is happening? The negative part of the reagent, see this is the negative part is bromine, Br delta minus is given. So this Br is attached to the unsaturated carbon, this unsaturated carbon, which contains less number of hydrogen atoms. See here, so the bromine will be added here. And this is the major product, isopropyl bromide. This is a major product. This is already explained in 11th standard, but purposefully I prepared this slide. In your textbook, this is not given. The clear-cut note is shown there. Please see the textbook of 11th standard. But I know for the revision purpose, I have given this slide. So you understand, I think you understand the Markovnikov's rule. And the next one is Anti-Markovnikov's rule. Again, only the 10 minutes are remaining. After 10 minutes, this lecture will be completed. For oxide effect. For oxide effect is also called as Anti-Markovnikov's rule. There are three different names, remember carefully. Peroxide effect, it is the effect due to the addition of peroxide. It is also called as Anti-Markovnikov's rule. It is also called as Kharash effect and Kharash-Mayo effect. What is this effect? I will explain now. See, if you understand the Markovnikov's rule, then Anti-Markovnikov's rule is exactly opposite to the Markovnikov's rule. In Markovnikov's rule, this negative part is attached to the carbon atom which contains less number of hydrogens. But in case of Anti-Markovnikov's rule, due to the presence of this peroxide, this situation is reversed. Negative part is attached to the carbon atom which contains more number of hydrogens. So this is a major product. See here, 1 bromopropane or propyl bromide is a major product here. And in case of Markovnikov's rule, see here Markovnikov's rule, this negative part is attached to the carbon atom which contains less number of hydrogens, and this is a major product. In Markovnikov's rule, 2 bromopropane is major product, and in case of anti-Markovnikov's rule, 1 bromopropane is major product. This is happening due to the addition of peroxide. That's why it is also called as peroxide effect, Kharash effect. These are the name of the scientists, Kharash and Mayo, who discovered this effect. Remember this note I have written in bold type. Peroxide effect is shown by HBr. Remember, whereas HCl and HI always add according to the Markovnikov's rule. Remember, this may be asked for your exam. So again, the second exercise is depend upon the Markovnikov's rule and anti-Markovnikov's rule. So go through this exercise. If you have any doubt, call me. These are the very important examples I have given. Then the next reaction is by halogen exchange. The name itself suggests halogen is exchanged in this. There are 2 reactions, Philkiston and Schwarz reaction, many board exams. In many previous board exams, these reactions are asked. So be careful. Remember these reactions carefully. I will also give the hint how to remember the reactions. See, in Philkiston reaction, it starts from F. Philkiston's reaction do not gives alkyl fluorides. It gives F gives iodides, and in Schwarz reaction we get fluorides. Means if the reaction starts from F, Philkiston, the product is not fluorides. I think this hint will be sufficient for you. Philkiston never gives fluorides. Philkiston gives alkyl iodides. See this reaction, RCl. One example, directly we will take one example, C2H5Br here. C2H5Br is ethyl bromide plus sodium iodide. This halogen is exchanged, iodine is exchanged here and bromine is exchanged here. So we get the products. We get the product C2H5I, iodides are prepared, and the byproduct is sodium bromide. So this is an example of halogen exchange. In this halogen is exchanged. This halogen of sodium iodide, iodine is exchanged here and bromine is exchanged here. We get the product iodides. And in case of Schwarz reaction, we have to use the metallic chlorides. Alkyl chlorides are prepared by heating alkyl bromides or chlorides in presence of metallic chloride. See this, some examples are given. All these are alkyl fluorides, AgF, COF2, SbF3 or Hg2F2, all these are alkyl fluorides. If these are used, again the halogen is exchanged here. Fluorine is exchanged to this Cl and Cl is exchanged here, AgCl. This reaction is called as Schwarz reaction. Many times this is asked for exam. So remember these reactions carefully. Philkiston reaction and Schwarz reaction. And one important thing, when in organic chemistry, as this is volatile chemistry, you will understand the reactions, but at the time of exam, it will get confused. So my request is daily, we have to make the practice, daily write down the reactions, read the reactions, and make practice of it. So again, some questions are given for the assignment. This is based on the previous, whatever the part I have taught. Gru's process, you know, Gru's process in this Lucas reagent is used. Now just I explained the Schwarz reaction. Explain the Schwarz reaction with example. This is a 1 mark question. This is a 2 mark question. Explain means it is asked for 2 marks. How will you prepare means this is 1 mark question. What is mean by Philkiston reaction? Explain with the example. This is again 2 marks question. How will you convert the ethyl alcohol into ethyl iodide by using PI3? Remember this PI3 is prepared in situ. This is already explained. This is again 1 mark. This is also 1 mark question. Write the reaction of the preparation of ethyl chloride by using thionyl chloride. This is a Darjan's process. This is also I explained how isopropyl bromide is prepared by using isopropyl alcohol. Yes, remember isopropyl bromide is prepared by using isopropyl alcohol by using HBr, but HBr being unstable, it is prepared by NaBr plus H2SO4 in situ. So the next part is electrophilic substitution reactions. In 11th standard, we already studied what is mean by electrophile and what is mean by nucleophile. Electrophilic substitution reaction means in this electrophile is substituted. Remember, electrophilic substitution means electrophile is substituted. Electrophile means positively charged species. See one example. Directly we will take one example. Aryl chlorides and bromides can be prepared. Now you are familiar with these words. Aryl. Aryl means the aromatic system in which one hydrogen is replaced with one halogen. This is called as aryl halides. Chlorides and bromides can be prepared by direct halogenation of benzene and its derivatives by using electrophilic substitution reaction. Remember the name. Electrophilic substitution means electrophile is substituted. Electrophiles are the positively charged species. Reactions are carried out in dark also at ordinary temperature in presence of Lewis acid. Lewis acid catalysts like Fe, FeCl3, AlCl3. See this reaction. Electrophilic substitution reaction. This is an electrophile and how the electrophile is generated by using this AlCl3 catalyst. In detail, it is given in also 11th standard aromatic compound chapter. This X2, out of this X2, one hydrogen here is replaced with X and another X. Sorry, we get the two products. One is ortho and one is para. See, one is ortho, second position, and one is para position. The para position isomer is more stable because it is less hindered away from each other, and this is hindered. CH3 and halogen, these are the closer. So this is a minor product and this is a major product, para halo toluene. This is a toluene. When, see in this example, it is given clear cut. When toluene is brominated, bromine is added in this, we get the two products here, orthobromotoluene and parabromotoluene plus HBr. HBr, this one bromine and one hydrogen replace here, we get here HBr. So we get two products here. Aromatic electrophilic substitution with iodine is reversible because you know HI is a very strong reducing agent. When the HI is prepared, again it will give the reversible reaction. In this reaction, we have to use the oxidizing agents like HNO3, HiO4 to remove HI. Means if you want, HI is not prepared here, so we have to use here oxidizing agents like HNO3 and HiO4. So HI will be not prepared. If HI is prepared here, again it will react and gives back the reactants again. So F2 being highly reactive, fluorocompounds are not prepared by this method. And if we want to prepare the iodine compounds, we have to use here oxidizing agents. Remember these two things. That's why I have written below. So remember these two things only for the examination. These reactions will be asked. These reactions will not be asked, so don't worry about this. Then this Sandmer's reaction. This Sandmer's reaction will be asked for. This is not asked for this year.